Hey folks, welcome to this episode of Molecular Formula. So as we've seen before, empirical formulas are the smallest whole number ratio of any element. The molecular formula is a formula that shows the actual amount of atoms of each element in that compound. So when we look at this over here, this is our empirical formula, and you can see that it's kind of the factor of all these different ones. For example, from here to here, we just divided by 6. From here to here, we divided by 5. From here to here, we divided by 2. So we can actually get a molecular or an empirical formula into a molecular formula by multiplying by some kind of factor. And this is what we're going to be looking at today. So when it comes to deducing the molecular formula, the first thing you need to know is what the empirical formula is. Because remember that the molecular formula is a multiple of that empirical formula. Sometimes the molecular formula is the same as the empirical formula. So it's critical that you have that formula. If you're not given it explicitly, you have to determine it by the way that we looked at last video. So if you don't remember how to do that, refer back to the last video because you'll need to know how to find that empirical formula before proceeding. Once you have it, all we do is simply calculate the molar mass of the empirical formula. So in the previous example, we had an empirical formula of CH2. So to find my molar mass, I have 1 carbon and 2 hydrogens, so that's 12.01 grams per mole plus 2 times 1.00 grams per mole, and I will have 14.01 grams per mole is my molar mass. So that's all we're going to be doing. We just find our empirical formula and we calculate the molar mass. Next thing is that we divide the molecular molar mass, and that's always given to you in the question, by the empirical molar mass, which is the thing that we just calculated right over here. And this will give you a multiplying factor. It could be 1, it could be 2, it could be 3. The number is not so important, but what you do with that number is that is our multiplying factor. So we're actually going to multiply the subscripts of the empirical formula by that factor to give us our molecular formula. So let's take a look at this one. So in this question, it says determine the molecular formula of a compound that has a molar mass of 78.11 grams per mole and empirical formula of CH. So it's actually made our life a little bit easier because our molecular or empirical formula is actually given to us in the question. So we don't have to go ahead and calculate it, it's right there. So the first thing that we want to do is we want to calculate the molar mass of our empirical formula. So that's just 12.01 grams per mole, which is the mass of carbon, plus 1.00 grams per mole, which is the mass of hydrogen, and so we're going to get 13.01 grams per mole as our molar mass of the empirical formula. My next step is I want to divide my molar mass of my molecular formula divided by the molar mass of my empirical formula. So I have that value of my molecular formula in the question in 78.11 grams per mole. And that's divided by 13.01 grams per mole as the molar mass of the empirical formula. So if we divide this through, my grams per mole cancel out, I'll be left with just a factor, and I get 5.999, which is rounded to 6. So my multiplying factor is 6. So I go back to my empirical formula, which is CH, but remember, if there's no subscripts, the subscripts are 1. So I'm just going to rewrite them that way, C1H1. And so what I'm going to do is I'm going to take this 6 and multiply these subscripts out. So I'm basically going to have 1 times 6 and H 1 times 6. And so what I'm going to get is C6H6. And that is my molecular formula. In this question, we're not actually explicitly given the empirical formula, but we are given a way to find it, and that's through the percentages. We are given the molar mass of our final compound and asked to find the molecular formula. So let's go ahead and figure out what our empirical formula is first. The first thing that we need to do is that we need to assume that we have 100 grams of sample, because that allows us to easily turn our percentages into gram values. So for carbon, I have 24.27%, and that's going to be equal to 24.27 grams. For hydrogen, I have 4.07%, which is going to equal to 4.07 grams. And finally, I have Cl, which is equal to 71.65%, and again, 71.65 grams. Okay, so that assumption of having 100 grams just allows us to turn those percentages into grams very easily. The next step is I need to turn this into moles, because that's the unit that we always want to go into. So grams per mole, I'm going to use a dimensional analysis I want to get rid of my grams. I'll put them on the bottom. I'll put mole on the top. Grams per mole, that's molar mass. Molar mass of what? The molar mass of the carbon. So if we look at our periodic table, that's going to be 12.01 grams for every mole. For hydrogen, that's 1.00 grams per mole. And for chlorine, again, that's going to be 35.45 grams for every mole. So what we're going to see is that our grams will cancel out, and all of these ones, grams cancel out, and we'll be left with mole. So our value for this is going to be 2.021 mole. And this one we have, just doing the calculations, 4.07 mole, and again 2.021 mole. So now we look at these values over here and we see which one is the smallest, and it's this one or this one. They're both the same value. So we take those, we divide all of the values by that number. So 2.021 mole, again 2.021 mole, and divided by 2.021 mole. So in this case, my moles will cancel out with each other, and for this guy I get a factor of 1, I get a factor of 2, and for this I get a factor of 1. So now this we can put our empirical formula together. So empirical formula is going to be C, and by C we have a subscript of 1, so it's just be C1, which we don't write the ones. For hydrogen, we have a factor of 2, so we're going to have H2, and finally for Cl, it's going to be 1. So CH2Cl is our empirical formula. Great. So now what we're going to be looking at is we have to figure out what our molar mass of our empirical formula is. So again, just like we've done before, we find out through everything and through the periodic table, and we have 49.46 grams per mole. So that's our molar mass of our empirical formula. To figure out what our multiplying factor is, again, we look at our molar mass of our molecular formula divided by the molar mass of our empirical formula. And so this value is 99 grams per mole, and this value is 49.46 grams per mole. So if we divide this out, we get a factor of 2. And what that means is that our molecular formula is the empirical formula times by the factor. So in this case, I look at that. So what I'm going to get is C2H4Cl2. So here's a question that says the percent composition of a compound is determined to be 32% carbon, 6.70% hydrogen, 42.6% oxygen, and 18.70% nitrogen by a combustion analyzer. The molar mass of this compound is 150.16 grams per mole. What is the molecular formula? So go ahead and pause the video, work this through, and we'll come back with the answer in a few moments. Welcome back. So here are the answers. So we get these factors. Carbon will have factor of 2, hydrogen 5, 2, and 1. And so in doing this, we have our empirical formula of C2H5O2N. After figuring out what our empirical formula is, we just figure out what the mass of that empirical formula was, divided by the mass that was given to us in the question, and we get a factor of 2. So all we do is we multiply that empirical formula by a factor of 2, or at least the subscripts by a factor of 2, and we get our molecular formula, C4H10O4N2. All right, that's it for this episode. Thanks very much for watching. See you soon.